Okay. All right. So we're going to start by finishing up a couple of slides from Friday. On Friday, we started to look at AJAX. AJAX is a method of loading little pieces of data from the server from within your web application. So web applications, oftentimes, they load an entire HTML and JavaScript sort of skeleton. And then from that point on, what they'll do is they'll make mini requests behind the scenes to the web server. And these requests are just like any other web browser request, except they happen without leaving the page. So we're on a page, we've loaded a page, gmail.com or whatever. We've loaded that page, and we never actually navigate away from that physical HTML file. When we click around and we send emails and we load inboxes and things, what the web page does is it communicates with the server behind the scenes to load additional data or to send additional data to the server without going through the traditional page fetch cycle. You click, the web browser makes a new request, you go to a new URL in the address bar, and the server responds with an entirely new HTML document. The entirely new HTML document has to be parsed and rendered and interpreted and everything, and so on. So it avoids a lot of redundancy. And it allows you to load additional pieces of data after the page has finished loading. So we got to the point where we had in our example, we got, let's see, lectures. In our example, our quotes example, we got to the point where we could fetch 5 new quotes maybe. And while we fetched the quotes, the page kind of went crazy. And it fetched a certain number of quotes from the quotes.php web service. So this is a PHP script which we have, which will give us a quote. Or if we pass in a parameter, I think it was like count or something equals 3, it'll give us 3 quotes. Yeah, there we go, 3 quotes. And the quotes are all formatted in HTML. This is sort of a snippet of HTML, right? I'm not even reading these quotes. Are these funny? Yes. Very, very true. Yeah, so this is a little HTML snippet. It's not a full HTML document. It doesn't have a doc type. It doesn't have like an HTML tag and a head tag and a body tag and all that. This is just like a tiny little snippet of HTML that's meant to be injected into another page. And that's what we're doing here. We're injecting this HTML into this page. So if you view the source of this document, we can't see the injected HTML. Firefox doesn't really update the source here, but if we inspect this page using Firebug, we can see that inside of this quote div we have these paragraphs. So we've injected these new HTML elements into this page. I want to do a couple more things, a couple more slides. Let's see. So the basic idea is we create a new XML HTTP request object. We did this on Friday. I like to call this an XHR object, just for short. We attach a callback function in advance so that when the data comes back, and we, in our code over here for the quotes web service, the quotes.php web service, we sort of made the request take artificially long just to illustrate the difference in time between when we make the request and when the data comes back. Usually it's not very long. It's only on the order of a few milliseconds, but there is a time gap there. So we make the request. The browser sends the request to the server takes a little bit of time to respond, and then it finally responds. The data gets sent back to the browser realizes that it has the data, and then what it does is it calls your callback function, and it supplies your callback function with the data that was returned. So we set that up in advance, then we actually send the request, and then this is in our callback function. Down here is our callback function. We do something with this .response text. This .response text is the field that contains the contents of the response. And again, if we go over here to Firebug, I switched to the Net tab here of Firebug. The Net tab is extremely important and extremely useful when debugging AJAX requests. So if I refresh the page here, it wasn't enabled when I loaded this page, but now if I click Fetch New Quotes, you can see that AJAX request was made. This additional request was made behind the scenes. In addition to, these are the files that were loaded when the page loaded, the HTML file, the CSS file, the JavaScript file. These were all loaded when the page was loaded, but this one was an additional request that went out. And we can inspect its contents. We can look at the headers. We're not going to really talk about headers today, but we'll talk about those, I think, on Friday. We can look at the parameters that were sent. There was a count parameter whose value was 5. And we can look at the response. The text of the response was this. And this is exactly what we saw. I mean, they're randomized. But if it wasn't randomized, then this is exactly the text that we would see if we just copy this URL, open a new tab, and paste it right there. Right? This is just a request, just like a regular request if we had just made it, by pasting this URL into the browser. We're getting, this is the literal text content that we're getting back. The browser is seeing that, and it's giving it to us, and we're able to inject it into the page. So AJAX is an extremely, extremely powerful tool and allows you to communicate with the server. The server is the only place, for the most part, that can save information. So we can submit information to the server, say like a tweet or a new Facebook post. We can submit information to the server without ever leaving the page. Just click tweet or just click, update my status or whatever. We send it to the server. The server records that, sticks it in a database, and then anybody who follows you or is your friend then is able to see that when they make a request to Facebook.com or Twitter.com to get their new information that's relevant to them. Now they see that. So this is pretty much why I mentioned on Friday, I talked about how this is kind of the first true revolution on the web. And this is really what made the web into a more powerful application paradigm than just a series of pages with information on them. So that's AJAX. I want to talk a couple more. I want to do a couple more slides with respect to error handling. So oftentimes an AJAX request will fail for whatever reason, and we need to be able to handle those failures elegantly. So we've set up in advance. We've set up this this onload callback function. Inside of this callback function, what we can do is we can check to see whether the request responded with an error status or with an everything was fine status. Servers will respond, and web services as well, will respond with different error codes to indicate whether something went wrong. 200 happens to be the code for, it's just called OK. Everything was fine. This is the information you asked for. Your request was successful. Here you go. Anybody know the status code for not found? 404, yes. Yes, good job. So everybody's familiar with that status code. There are some others too. There's 403, I think, is you need to authenticate or something. You haven't authenticated properly. You can't see this. You don't have the permissions because you didn't authenticate. 400 means you submitted bad parameters or somehow you made a bad request. It's your fault. You did something wrong. Correct your parameters and then make the request again. 500, anybody ever seen a 500? That's it's called an internal server error. We'll talk about these more on Friday, but it's called an internal server error. That means I messed up. I'm the server and something went wrong. My bad. So we'll talk more about those on Friday, but inside of this this callback function, we can differentiate between whether the request was a good request, it completed successfully, or whether it didn't. What we can also do is, and this is slightly different from there being an error status in the response. We can also set up an on-error event handler in advance. Let's see. Oh, actually, this might actually be the same. On failure, error, making. Yes. Okay. So this is the same. I'm sorry. There are lots of different paradigms in handling errors in Ajax, and I'm used to a different one. So this is one way that we can handle an error. This is another way that we can handle an error. In advance, we can set up a different function to be run if there's an error. And there are two different types of errors. There are the error that the server sends back to us. It says, okay, well, you made a bad request, or the file you requested wasn't found. It responds to us and tells us that its response is an error message. Then there's the type of error where the browser doesn't even make the request. You can't even find the server. You don't have an internet connection. The browser blocks the request due to security restrictions. So there's like a separate class of things that can go wrong. I think they're generally referred to as exceptions. So if that happens, then this function will also be run. So this function will be run if there's if the status is anything other than 200, anything other than OK, or if the browser was just completely unable to make the request to begin with. And inside of our error function, we can do something with, so this is an exception. This E parameter will be an exception if there was one. We can do something with that. We can do something with status text. Status is like the error code, so like 404, and then status text would be whatever description of that the server gives to us, which usually is not found in the case of 404. Okay, so an example error handler, and you're welcome to use this exact error handler in your homework assignments. In fact, we'd recommend it. Actually, I think on the next homework assignment we might actually require it. But this is a great error handler. It just sort of alerts a message that says something went wrong, there was an error making the request, and it gives you some information about the server's response. It says, this is the server's response, 404 not found, for example, and this is the text of the server's response. If the request was never able to be made to begin with, then all of this stuff will just be blank. This will just be null. And usually what will happen is the browser will give us an exception, and that exception will be thrown instead of this alert actually, instead of this alert actually giving us useful information. The browser will give us useful information when we throw the exception. Yeah.
So I think the Ajax object is like very similar to document object when we think about the event handling. Does it work?
Mm-hmm.
Add event listener. Does it work for Ajax?
That's a really good question. He said the event handling for this Ajax object, we're attaching an onload event handler and an on-error event handler. The event handling is very similar to the regular document when we attach event handlers to things in the DOM. And can you use add event listener instead of these onload and on-error? I don't know, actually. That's a really good question. I'd look it up right now, but maybe you can just look that up on your own. I suspect that, well, I don't know. Actually, it could go either way. It'd be great if you could, because then you could attach multiple functions to onload or to on-error. But typically, like if you're making this Ajax request, you don't need to worry about anybody else trying to attach other event handlers to this Ajax request. You just know that you want to run this single function at the end. So it might not even matter. But good question. Okay, so this Ajax failure function will be executed if you attach it there, and this will give you some useful debugging information. Other ways that you can debug the Ajax, your Ajax requests, probably the best one to use is to just keep the net tab open just all the time. The net tab and the console, actually, so the console New requests, like the AJAX request, show up in the console as well. And this is also where exceptions and errors get shown. So if you just open the console, if you just leave the console open, and as soon as you make a request, you'll be able to see like whether there was an error. In fact, why don't we just introduce an error to our code? So the script is called quotes.php that we want to make an AJAX request to. Let's mess that up. Let's just call it quote.php. Oopsie. And then we'll refresh the page. Uh-oh, not found. Let's see. So this request was made, and Firebug is highlighting it as red because the response code was non-200. The response code was not 404 not found. And this is the response. The response is being given to us by the web server. The web server is the thing that handles each request and says, okay, I know that there is a file there that you're looking for. I'm just going to execute that PHP script or whatever and send you its output. But if this PHP script doesn't exist, then the web server intervenes and it gives us an HTML document that says this thing was not found. And this is exactly, again, this is exactly what we'll see. If we copy that location, open up a new tab, paste it in the browser, we see this full HTML document, right? So it's giving us an error message. We happen to be injecting all of that HTML into the page here. Let's adapt this so that, I mean, this is kind of weird because we're trying to inject like an entire HTML document with like doc type and title and all that stuff into this page, and that's weird. Like you can't really do that. You can't inject an HTML document into an HTML document. You can only inject like snippets of HTML, like a paragraph or H1s or whatever. So that's why it's only interpreting these like title and H1 and P tags here. So let's handle this differently. Let's introduce that AJAX error handler function that will allow us to alert when there is an error. So let's go back to the slides, and so we'll just basically copy this. On error equals AJAX failure, and we'll just copy this AJAX failure function here. You should probably just get in the habit of doing this, just copying this AJAX failure function here. Okay. Okay, so error making AJAX request. So, and then up here in advance, we set up, in addition to onload, we'll say xhr.onError equals AJAX failure. Again, no parentheses, right? No parentheses. Then we refresh the page, fetch new quotes. Oh, what did I do wrong? So that is that. On error equals AJAX failure. Am I in the right place? 19. Am I editing the right file? Yes. AJAX failure exception. On error equals AJAX failure. It's the right function. What's the problem here? I'm still injecting the stuff into the page. Okay, so I might have misinterpreted this actually. So I interpreted it correctly the first time, I think. So we might need to do this inside of our onload.
The on error is
Only
only for server errors.
for server errors?
But here our errors are happening on our end because we're passing the wrong.
No, well, so the server, oh, so only for like 500s then? It should be for like any error status, right? Well, okay, let's adapt this and we'll figure this out. I'm used to doing this a little bit differently, so let's just go ahead and add this inside of our onload event handler, we'll check to see whether the status was good or bad. Got new quotes, this is our event handler here. We'll check to see if the status is good or bad. Indent properly. Status is good, then we'll do the stuff that we were doing before. That stuff there. Otherwise, we'll handle the error. Maybe we'll just, in here we'll call Ajax failure. Pretty roundabout way of doing it, but we'll see if that works. Not supposed to do that either. This is bizarre. Okay, let's see. If the status is 200, okay, the status is not 200. So why are we? So this is set interval. Oh, okay, yeah. So okay, we need a clear interval in either case. Okay. Okay, we need to clear the interval timer regardless. Let's see. Else Ajax failure. Okay. Type error, this is undefined. Okay. Alert. Something went wrong. Okay. Okay, so now we've at least determined that something went wrong. This is weird. Like, I'm used to error handlers doing handling anything that's like a non-200. But I guess maybe this only handles like exceptions. In which case, I'm not sure why we'd want to use this .status and this .status text in here, but that's okay. Yeah.
I'm wondering if there's some keyword to try exception used inside of another language that might be in the script or not. Keyword.
A keyword in
JavaScript that has you might try an exception as a keyword. Some people that find errors. It's not in the JavaScript, but
Does JavaScript have an exception keyword?
oh, an exception.
Like other languages have.
So in JavaScript, there's the concept of an error. Actually, it's not actually an exception. I think it's called an error. It's the same kind of object, and this, well, so we're just sort of calling this object exception. We call it E or whatever. I think it's technically considered to be an error, just like the name of the object is like runtime error or something instead of runtime exception. But this is the thing that we can throw. Just like in Java, we can throw this thing, and that will result in an error out here. So let's go ahead and do that. Oh no, we can't because this was not an exception. This is a regular error. Okay. Well, at any rate, so we can do something here when something goes wrong. And Ajax failure down here, we can. Let me see if do I want to. No, I can't really do that. Yeah. Any rate, so we can handle it differently if there was a different status other than 200 here. Now let's make it an exception. And the way that I'm going to make it an exception is I'm going to try to load this from Webster. When I'm not currently running this on Webster, I'm currently running this on my own local machine. I'm going to switch to trying to load this from Webster. So I'm going to say, https://webster.washington.edu/mducey/quote.php, whatever. I don't even need to actually upload it there. I'm just going to use this for illustration. I'm going to try to load this from a different server. Okay, that's the point. I'm trying to load this from a different server from the one I'm on. And this will result in an exception. So fetch new quote. Oh, error. So we actually get this exception here, uncaught exception, progress event. I don't know what that is, but so what happens here is Ajax. Get rid of that. There are rules about where you can load information from using Ajax, and the biggest rule is that you can only load data from the same server that you're on. So I can only make an Ajax request back to the same server. It's called the same origin policy. An Ajax request can only be made to the same server that the JavaScript code originated from. So because my JavaScript code is originating from localhost, I'm local hosting, I'm running this on my local web server on my own computer. I cannot make a new an Ajax request to webster.cs.washington.edu. I can't make it to google.com. I can't make it to any other domain other than localhost. Likewise, when you're running your code on Webster, you can't make an Ajax request to any other machine. You can't make a request to my machine here. Obviously, you can't do that. You can't make a request to google.com. You can't make a request to Facebook. You can only make a request to webster.cs.washington.edu. So this is in place because of security restrictions. There are ways you can get around that, which we'll discuss in the extra session on Friday. But for the most part, you are only able to make Ajax requests to the same server. Part of this is, and I think this differs between browsers, part of this is that you can't actually make an Ajax request if you're loading something with, if you just do like file open in your browser, you can't, the page that you open can't make an Ajax request. You have to actually be viewing it from a web server. So you have to upload it to Webster and view your page on Webster in order for the browser to allow it. Yeah?
What about the case where you have, say, an HTML document and you include a script that's not on the server your HTML document's on? So, like, let's say you include a script from Webster and you're not loading on Webster. That script can run things from Webster, but your page cannot.
Yes. So he said, what about if you load a JavaScript file from a different server? The same origin policy applies to the JavaScript code that gets run. So if the JavaScript code comes from another server, that JavaScript code can only make Ajax requests back to that same server. It can't make Ajax requests to the server that your code is on. And so your page, it's the JavaScript code that's restricted. It's sort of sandboxed, and the browser says this JavaScript code came from that source. It can only make requests back to that source. Mm-hmm. If you're using localhost, you can. Localhost means you're making a request to the web server on your computer. So, I'm running a web server on my computer right now. Mm-hmm. These are all stored on my computer. They're all in a particular directory. So this is like, if we just go to just like localhost here, we'll just delete everything but localhost. This is my root web directory that I have set up somewhere on my computer, and this is where I put all of my web stuff, all of my web files. I put in this directory, and and my CSE 154 stuff is in these directories. So when I make a request to localhost, I'm making it through. I'm like actually my browser is contacting port 80 on my own computer and communicating with the web server program on my computer, as opposed to if I just go file open. If I just do file open to try and load quotes.html. So you can see that there's a file URL here. The browser is just loading this file directly via file open. It's just looking at the file system to load this file. And actually, we haven't modified our code to make it unexceptioned yet. Quotes.php. Something went wrong. Let's see. Actually, so this is where there are some browser differences. Firefox might actually be making this Ajax request. Nope, doesn't look like it is. Yeah, something went wrong. So Yeah, so you can only make AJAX requests to the same server, and you can't make AJAX requests if you loaded your file just by doing file open. Did you have other questions about localhost? Okay. Okay. So lastly, if you want to do a post request, you have to do that a little bit differently. You have to create this new object. It's called a form data object, and then you add parameters to that with their values, and then so when you open the AJAX request, you use post instead of get for the first parameter. Usually we use get for the first parameter, and then we just do the URL. And then when we send, normally we send with like, just an empty, no parameters, but we pass this form data object there instead. So that's how we do a post using the XML HTTP request object. Okay, I'm going to get to the new material for today. New material for today is yet another language. It's called XML. It's actually, it is another language, but actually it's not, because we've been using XML in the form of HTML all quarter. Yeah, exactly. Wow, I already know it. That's cool. So this is an example of storing complex data in a really lame form. So we've got, we're trying to store a note here with like an origin, a recipient, a subject, it's like an email kind of thing, a message, information about its privacy and stuff like that, its language that it's written in, the human language, and so on. This is a really lame format because we have to treat this entire thing as a string. If we loaded this file, say with an AJAX request, we would, do something with, this.response text, and we would have to treat this like a string and parse it manually. We'd have to do like substrings and look for these colons and stuff, and like what if there's a colon in the message, and like we'd have to look for this begin and end, and like we'd have to. It's just really, really difficult to be able to parse this. So we would like to be able to get information in a format that we can readily parse and we can just extract information from easily. And that's where XML comes along. XML is actually the X in AJAX. XML was originally the sort of the raison d'être for Java for AJAX. It was the reason why AJAX was the most frequently used method of fetching information using AJAX. An XML document looks just like an HTML document because HTML is actually a version of XML. At least the previous iteration of HTML was. The current one is a little bit more lax, but this is the structure of an HTML document. It starts with what's called the XML prologue. This is just a little thing that indicates that the document is XML. It's the equivalent to the doc type in HTML. And then from that point on, we just got a bunch of tags, a bunch of elements and attributes that look exactly like HTML, but the only difference is that the tag names and the attribute names are just completely different. They can be whatever you want. If you just want to make up your own flavor of XML, they can be whatever you want. Or there are lots of sort of sub-languages written in XML. HTML is one of them, but there are a lot of them. There are let's see. So there are XML languages used for music. There's one called Music XML. There's one for math called MathML. SVG allows you to represent vector graphics using XML. On this slide, we've got an example of this is Music XML. So this is the Music XML to represent a single measure. A measure is like a thing in music. Attributes for this measure. A single note here is represented by this. We've got a pitch, represented by a letter and an octave number, duration, this is going to be a whole note, so on. So this is a representation of music. So we can use XML to mark up anything, any type of data we want, any sophisticated, complex type of data we want. This is how we would mark up the note that we had before. So we've got a from, we've got a to, we've got a subject, we've got a message, and where before we had this like little parenthesized English whatever, we've got now an attribute here. This is sort of metadata about this message. It happens to be written in English. And then we've also got metadata about this note. It happens to be private. We had previously put that down here in just this weird spot. So lots of data is represented in XML. Why? Well, it's really it's a very universal format. It's very interchangeable. It's also very self-descriptive. You wrap tags around something, you know exactly what that thing is supposed to represent. It just describes itself. It's pretty great. So XML is not really a language in itself. It's more of the skeleton, the framework for creating a language. When you create a sub-flavor of XML, you decide what the tags are for that language, you decide what the attributes are, and you decide the rules about how they go together. HTML has its own tags, h1, div, p, and so on. It also has its own attributes, ID, class, source, href, and so on, and rules about how they go together. For example, some elements have to be contained inside some other elements. In HTML, inline elements have to be contained inside block level elements. So these are all things that are imposed by HTML. They're not inherent in XML, but any language you create in XML can have all of these attributes. So we talked about the anatomy of an XML file, uses. It's pretty much the universal interchange format. If you want to give someone information, if you dump it in XML, they'll be able to read it. Oftentimes people communicate data that way. Not always. Sometimes people just output like SQL dumps or whatever, or they sometimes export to sort of proprietary binary formats that are smaller, but oftentimes web servers will communicate or store data as XML files. Databases can return query results in XML if you want them to, and web services use XML to communicate. We'll talk more about web services on Friday. Did I see a hand?
I was just curious about how CSS played into the concept of XML.
The question was, how does CSS relate to XML? So browsers can actually parse XML pretty much like they parse HTML, and there are ways that you can actually include stylistic information in an XML document. So you can actually just import a CSS file that uses exactly the same syntax as the normal CSS code, but it styles different tags. So you wouldn't style h1, you'd style like the subject tag, right? In CSS. So you can do that.
So if you were to take a musical XML file
Mhm.
and you were to like display it as shoes, you could have some kind of like language you could style that with then.
So music would probably be different. CSS is intended for like just plain text documents, and music has a completely different structure. The musical notation is very different. CSS is not intended for that, so I don't think that you'd really be able to use CSS for a document like that. I don't know. I bet you. I don't know. That's a really good question, because I could see like wanting to render musical notes in different styles, or use different fonts for the lyrics and things like that. But I don't really know how those would relate. Good question. Anyhow, so what tags are legal in XML? Any tag you want. If you want to represent a library, you might use these kinds of tags: book, title, and author, and so on. So you basically just come up with the XML yourself. AJAX is oftentimes used to fetch XML documents and analyze the data in that XML document, and then basically allows you to extract information from the XML document, and then use that information, maybe inject that information into the HTML document. So we're getting XML, we analyze the XML, extract information from it, and then separately we use that information to create new HTML tags or whatever and inject the HTML tags into the document. So, and there is an XML DOM similar to the HTML DOM. This is really why browser makers decided that that XML would be a great choice for like loading complex information, because it happens that the browser already knows how to parse XML. Because of the fact that it knows how to parse HTML into a DOM, it can also parse XML into a DOM. And so we can use the same standard HTML DOM methods to get information from an XML document. So if we want to get access to an XML document, if the information that we're loading is XML, what'll happen is we could still use .response text if we wanted to, but that's a string that contains the XML code. And that's not super useful to us. Then we'd have to actually go about manually parsing the string as well. And we're back in the same boat as we were way back in the beginning. So that's not very useful. But what the browser does is there's also a second object, response XML. And this will be populated if the data that we fetched was XML. The browser will automatically parse that and put a document, an XML document, in this object here. Just like the document object, we use document.getElement by ID, document.getElement by class name. This is that kind of thing. We can say this.response.xml dot get elements by tag name. This.response.xml dot query selector all. We can do all of these standard DOM things on this response XML object, and we can find information inside of elements and extract that information to be able to use it. So if this is our XML document, we have a categories root element, and then each of its children are different single category elements. So we've got ajax.response.xml is the root document. Inside of that, it has a root node of categories, and inside of that, it has, in this case, it has several children. We've still got these useless white space text nodes here because there's that thing right there, and then there's that thing right there, and then there's that thing right there. All of these white space text nodes in between these actually useful elements. So we've got this white space, a category, more white space, a category, and so on. This category has a child that's a text node whose contents are like the text inside of it, right? So this is exactly like the HTML DOM, exactly like the HTML DOM. And so we can use getElements by tag name. We can use query selector all and query selector. One of the major differences is that in HTML, just as sort of a shortcut, instead of using this stuff to get like the text content, like this children, if we wanted to get this children text content of this category tag, we would use .innerHTML, just because it's quick and easy. But we can't do that in the XML DOM because it's not HTML, it's XML. So we use something else instead, that node.textContent, or we look inside of this node, this category node, for its first child, which is a text node, and then we get that child's node value. Node value just is the basically the text content inside of it. So these are the two different ways that we get content out of a tag in XML. And actually, we could do either of these in HTML too. So everything on this page applies to the HTML DOM as well. In this case, we just usually go about it differently. We use .innerHTML. So because HTML is a subset of XML, everything that applies in the XML DOM also applies in the HTML DOM, but the reverse is not true. So there are some things specific to HTML in the HTML DOM that we can't use in the XML DOM. For example, get element by ID. We can't say this.response XML.get element by ID. And that's because in the particular flavor of XML that we're using, we can't rely on an ID attribute being legal. Like that XML flavor might not have such thing as an ID attribute or a class attribute. Those are specific to HTML. So we can't use ID or anything related to classes on this.response XML. Yeah.
Could you write a method in JavaScript called get element by ID where it takes say a string parameter and it looks for an attribute name?
You could do that. Yes, you could do that. You could write a function that parses, that goes through the XML DOM and looks for something with a particular ID. You could do that. Which actually reminds me, so you asked about CSS earlier. So the rules of CSS would be different then. You couldn't use hash for IDs and dot for class because ID and class don't apply to XML. You could use tag names, and you could use attribute selectors. So you could say, if you had an element foo, you could say, ID equals bar. You could use that. If ID was a legal attribute in your flavor of XML, you could do that. Do that. So this is another valid syntax in CSS. The way we usually use this is for input tags. Input type equals submit, for example, or password or whatever, radio. So all this is an attribute selector. So you can do that. Okay, we can't use inner HTML, like I said, and we also can't get specific. We also can't get an attribute using just that attribute name. So this is something that browsers use as sort of a shortcut in the HTML DOM. If there's an attribute called source, then this DOM object will have a .source property. But the XML DOM doesn't work that way. In order to get an attribute, you have to use .getAttribute to get that attribute, which you can also use in the HTML DOM. You can say document.getElement by ID myImage.getAttribute source if you want to. It's just that browsers sort of automatically add this property if it's there. That doesn't happen in the XML DOM. Okay, some examples of extracting information from the XML DOM. So if this is our document, we have an employee's root tag, we have lawyer with an attribute of money, we have janitor, blah, 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 we have another janitor. So if we want to get the money attribute of this lawyer, then we would want to do this.response XML.querySelector lawyer. Why do we do this instead of querySelector all? Yeah, well, because we know that we only have a single lawyer in this document, and querySelector all would return an array containing just that single lawyer. So if we did querySelector all, we'd have to like add a bracket 0 at the end of this, which would just be lame. So we're just going to get the first one that it finds by using querySelector. So that's the lawyer object there. Then we can call parseFloat on lawyer.getAttribute money. So the lawyer object, we're going to get its money attribute, and that's this. We're going to parse that as a float, and that's now a number. Let's see, janitor. So this.response XML.querySelector all janitor. This is now an array of the 2 janitor elements we have on the page. So the 0th janitor.querySelector vacuum, that finds the vacuum element inside of that janitor. .getAttribute model, that's the model of the vacuum. I've always found this to be a bizarre example. The 1th janitor.text content, that's the text content inside of the opening and closing tags. So there we go. Okay. A larger example of a file, we have a bookstore here with a bunch of books. Each book has a category. title, author, year, and price. And then, so we can say this.response.xml.getElements by tag name book. That will be a list of books. We could also say just query selector all book. Iterate over the books. For each book, we're going to get its category. If category is computers, then we will get the title, the author, make a P tag. So we'll say document.createElementP. Now we're sort of getting the information from the XML DOM and we're going to put it into the HTML DOM. We're making a new P tag. We're setting the P's inner HTML to be the title, comma, space, by, space, author. And we're going to append that to the body of the document. So we're creating new HTML content, injecting that content in the page that we extracted from the XML document. Yeah.
So at what point in file size is it recommendable to switch from XML to SQL? Because SQL is a little bit faster in terms of database parsing, and so the difference between XML and a database is usually, I would think, amount of data you're trying to store and access.
Mm-hmm.
So when you go, like when you were in this example looking at different books, once you get to a certain size of books, you don't really want to be storing in a giant XML file. It'd be more efficient to store it in an SQL server, right?
So the question was, at what point should you switch from XML to SQL because SQL is more efficient? Well, so if you want to store information and retrieve information quickly, and you have a lot of it and you have a lot of records, it's best to store it in a SQL database. If you have maybe, so I think of using XML for like, I often use XML for like configuration stuff. Like on web servers, I will store config files in XML, or in the language that we'll learn on Wednesday, it's called JSON. I'll use one of those formats to store configuration stuff, which is, you don't typically have tons of the same kind of record. In that instance, you have a bunch of different things with different properties and stuff, and so I tend to use this for just stuff that doesn't have a whole lot of repeated structure. This has a lot of repeated structure, and if we were actually storing all this information, we'd probably want to do it in a database if we had more than like 4, but it's still a good example of like structured information. Good question. Okay, we're gonna skip that, and we're gonna sort of try to get started on this one. We're not gonna finish this today, but we'll continue this on Wednesday. So this is an example that we like to do every quarter. We're gonna use a web app called animalgame.php. I don't know if you've used the animal game before. Let's look at the animal game. So the animal game, this is kind of a kid's play toy kind of thing. This works almost exactly like if you take in 143, you did the 20 questions. The 20 questions homework assignment. This is basically just that. So it asks us a series of questions. So we think of an animal in our head, and it's going to ask us a series of questions to try and narrow down what animal we're thinking of. So, can it fly? Yes. Does it have feathers? Yes. Does it sometimes live in water? Yes. Does it eat fish? Yes. Does it have long legs? I'm just going to keep clicking yes. Is it pink? Sounds like a flamingo. Does it look weird to humans? I guess I'm thinking of a flamingo. Does it sometimes stand on one leg? It's not pink or stands on one leg, is it? Yes. How do I respond to that one?
Wait, how was that not?
I don't know. I don't know how that wasn't a flamingo. So the thing about this, yeah, there's no way I can respond yes or no to this one, is there? There's no possible way. So like the thing about this is it's user contributed. So if you get to the end and you stump it, you're like, nope, that wasn't the animal I was thinking of. Then you can say, okay, well, just like with the 143 20 questions, okay, give me a question that differentiates between my guess and your animal, and then what is your animal? Tell me what your animal is. So and it adds that to the tree. So I think if I just keep, is it not real? Are you going to keep hitting yes? Does it have stripes? Is it white? Is it a male? Is it yellow? Is it related to the cat family? Can it be all what? So so I mean obviously are you gonna click yes for the last question?
Our version of this program is way better than this one.
Are you going to enter no?
Can it do everything? Are you gonna click yes forever? Yes. Is it really smart? Yes. Is it delicious? These are all new. Like these are 2012. I haven't seen these yet. Our dump of this ends like. So we finally got to the end of something. So when we get to the end, like we can either answer yes or no. If we answer no, then oh, you stumped me. I thought you were thinking of that. If you log in, then you can click Teach Me, and you can give it what animal you were thinking of, and a question to differentiate between this animal and yours. So what we're going to do, and we'll start this on Wednesday, is you'll notice that we've each time we clicked a button, we were continuing to a new page. We were actually visiting a new URL in the browser. What we're going to do is we're going to write, let's go to example, XML, animalgame.html. We're going to write this. This is going to make requests to, make AJAX requests to the web server. And we're going to fetch a new question, and the question is going to come to us in XML format. The server web app is, let's close some of our stuff here. So this is the web app that we're going to be making a request to, animalgame.php, which lives on Webster. The first node, the first question has a node with an ID of 1. It has a question, and if the answer is yes, then the node ID to proceed to is 13. If the answer is no, then the node ID to proceed to is 5. So if we want to answer yes, then in our JavaScript code, we want to extract the node ID from this, and we want to make a new request to this web service with the node ID of 13. That will be a new node. Does it have feathers? Yes. You know, we can just keep going like this. Does it sometimes live in water? Yes. And so on. So we'll be using JavaScript code to respond to click events on the buttons and make new AJAX requests to this web service. Yeah.
Why are the two IDs to go to for the first question 13 and 5 and not like 2 and 3?
That's I don't know. The data sort of grows organically. So you know sometimes data gets removed, sometimes data gets added. You know I don't know. That's how it just sort of evolved. So I'll see you guys on Wednesday.